Have you ever wondered why, when you're in a pool, why it's harder to walk through water? You feel as if the water's pushing you back. Why is this?
This effect is due to the drag force exerted on your body. Drag is the result of an object's leading surface colliding with molecules of the medium it is traveling through. Drag force is a resistive force caused by movement through a liquid or gas. Factors affecting this force include shape, mass, and velocity of the object, as well as the density and viscosity of the fluid. In free fall, as the speed of the object increases, the drag force increases. At some point, the resistive force will be equal in magnitude to the force of gravity, and the object will reach terminal velocity.
Now imagine if you were swimming through a pool of honey rather than water. Would you expect it for it to be harder to swim or easier? You'd probably say harder, but do you know why? Is it because honey is denser than water? Today, here at Physics Busters, we will be investigating the effect of density on drag force.
We will be testing 4 fluids: water, dish soap, vegetable oil, and rubbing alcohol.
The experiment will be conducted by placing each fluid into the vase, filling it to the rim. A 5-gram marble will be placed just below the surface. It will be then released from rest, and this will be done 3 times for each liquid. Each liquid was placed into a 100 milliliter graduated cylinder. It was then placed on a scale, and the density was calculated using the formula density is equal to mass over volume. results from the experiment show an inverse trend with density and acceleration. Generally, as density increases, acceleration decreases. It is also evident that there is a direct trend with density and drag force. As density increases, drag force increases. However, as seen in the graph, vegetable oil is an exception. This could be a result of the viscosity of the fluid. Viscosity is the state of being thick, sticky and semi-fluid inconsistency due to internal friction. A liquid can be denser than water, but not as viscous, or more viscous than water, but not as dense, and such is the case with the oil. Throughout the experiment, the controlled factors included the volume of the fluid, the distance the marble traveled, the temperature of the environment and fluid, as well as the mass of the marble. One variable that could not be controlled, however, was viscosity. Usually, as viscosity increases, drag force increases as well. In the case of oil, it had a higher viscosity than water because the particles in oil have a stronger attraction force than the particles in water. This accounted for its increased drag force. Other than this exception, the rest of the results follow the general trend.
In conclusion, there is a direct relation between density and drag force. This is also proven with the drag equation. Fd represents the drag force, while P represents the density. As P increases, so does Fd. Thank you for watching this episode of Physics Busters. Tune in next week when we solve the mystery of how satellites stay orbiting